If you look at the Earth from space, the first thing that catches your eye is the ocean. It covers most of the planet's surface. Vast expanses of water stretching to the horizon seem familiar and almost well explored. We've crossed the oceans on ships, observed them from satellites, and even dived to their deepest points. But there is one detail that is rarely thought about. We know almost nothing about what lies beneath the ocean's surface. Modern technology allows us to explore distant planets, study the surface of Mars, and observe galaxies billions of light years away. Yet, a significant portion of the ocean floor remains virtually unexplored. Some areas of the ocean have only been superficially explored. Others have never been observed by humans. This means that right now, beneath the water, there is a world hidden that we know very little about, a world with its own terrain, structures, and perhaps phenomena that we do not yet understand. In this film, we will travel to the depths of the ocean to see what is really lurking at the bottom, and perhaps understand one simple thing. We are just beginning to study it. When people think of the ocean floor, a rather simple image often comes to mind. A dark, flat, and almost empty surface, hidden beneath kilometers of water. Something lifeless and monotonous, where almost nothing changes. But this idea is almost entirely wrong. In fact, the ocean floor is one of the most complex and diverse landscapes on Earth. If all the water suddenly disappeared, we would discover a world that would look more like an alien planet than the Earth we know. Hidden beneath the ocean are mountains, canyons, valleys, and plains. The scale of these structures is so vast that many of them surpass anything we see on land. One of the most impressive examples is the Mid-Atlantic Ridge. This gigantic underwater mountain chain runs across almost the entire Atlantic Ocean. It stretches tens of thousands of kilometers, making it the longest mountain system on the planet. But the most amazing thing is how it is formed. Along this ridge, the Earth's crust literally pulls apart. Molten rock rises from the depths, solidifies, and forms a new ocean floor. This process is constant, albeit very slow. This means that the ocean floor not only exists, but is being continuously created right now. But if the mountain ranges form the skeleton of the ocean, then between them lie vast plains. These plains appear calm and almost empty. However, it is here that processes occur that can be compared to the slow settling of time. Over millions of years, tiny particles, remnants of organisms, dust, minerals, settle to the bottom, forming thick layers of sediment. Sometimes the thickness of these layers reaches hundreds of meters. Each layer is like a page in the book of Earth's history. They preserve traces of ancient oceans, climate change, and even the aftermath of catastrophic events that occurred millions of years ago. But perhaps the most impressive landforms are hidden not on the plains, but in the depths. There are canyons underwater whose size is difficult to imagine. Monterey Canyon off the coast of California, for example. It begins just offshore and extends into the ocean, reaching depths of over 3 kilometers. In terms of scale, it's comparable to the largest land canyons, and in some places even surpasses them. These canyons are formed by powerful flows of water and sediment that slowly erode the seabed. But the ocean is not limited to ridges and canyons. It also contains underwater mountains, the so-called seamounts. These are isolated peaks that rise thousands of meters from the ocean floor but do not reach the surface. Scientists estimate that there may be more than 100,000 such mountains in the world's oceans. Many of them have not yet been studied in detail. One of the reasons for this is the difficulty of observations. Unlike land, where the terrain can be seen directly, In the ocean, everything is hidden underwater. Light doesn't penetrate to great depths, and the pressure makes long-term human presence impossible. Therefore, scientists obtain most of the information about the bottom relief using sound. Special devices send sound pulses downward, and the time it takes for them to return determines the depth. Maps are created based on this data, but such cards have limitations. They give a general idea of the seabed's shape, but they don't allow you to see the details. It's like looking at a landscape through a blurry glass. You can see that there are mountains and valleys, but you can't see what exactly they look like. And that is why the ocean floor remains largely unknown. Sometimes, when diving into certain areas, underwater vehicles discover structures that have never been previously recorded. Unexpected elevations, unusual landforms, complex geological formations. Each such discovery reminds us how limited our knowledge is, and herein lies one of the most amazing paradoxes. We've studied the surface of the moon in detail. We know the topography of Mars better than we know the underwater topography of our own planet, but the ocean remains hidden. It is not fully revealed to satellites or cameras. It requires slow, complex, and expensive exploration. And that is why structures that humans have never seen before continue to exist beneath the surface of the water. Mountains that have never been photographed, canyons that cameras have never peered into, plains that we know about only from indirect evidence. And the more we learn about the ocean floor, the clearer one simple idea becomes. We see only the general form of this world, but its true details are still hidden in the darkness of the depths. When we think of unexplored places on Earth, we often imagine distant islands, jungles, or polar regions. But in reality, the biggest blank spots aren't on land. They are hidden beneath the ocean. On a map of the Earth, the ocean appears as something studied and understood. Satellites constantly monitor its surface, ship routes are known, and its depths, it would seem, have long been measured. But this is only an illusion of knowledge. Yes, we have maps of the ocean floor, but in most cases, these aren't precise images, but rather generalized models created based on limited data. They show large features, ridges, troughs, and rises. But if you try to look at the details, it becomes clear. A huge part of the ocean remains a blur. To understand this, we can give a simple example. The resolution of many seafloor maps is comparable to an image, where a single pixel is several kilometers in size. Imagine trying to view a city, where a single pixel represents an entire neighborhood. You'll see the general shape, but not the streets, buildings, or details. This is how we see most of the ocean. However, there are places where the situation is even more difficult. Some areas of the ocean have been virtually unexplored directly. No cameras have been deployed there, no detailed surveys have been conducted, and data is limited to approximate depth measurements. For example, large areas of the Southern Ocean around Antarctica remain poorly explored. Harsh weather conditions, ice fields, and remoteness make expeditions there extremely challenging. There are also areas in the Central Pacific Ocean where the depths are enormous and the distance to the nearest land is thousands of kilometers. Getting there is a challenge in itself. Conducting a full-fledged study is even more challenging. But even in relatively studied oceans, there are still zones that only a few have seen. For example, the deep Atlantic Ocean, far from major shipping routes, is rarely explored. Expeditions there are sporadic, and each covers only a small area. This is why much of the ocean floor still remains unknown in detail. But it's not just about distance. The main problem is depth. At depths of several kilometers, the pressure becomes so intense that most conventional materials simply cannot withstand it. Specialized equipment capable of operating in such conditions is rare and expensive. Their use requires complex training and significant resources. Each dive is a separate mission, and even during such a mission, only a small area is explored. Imagine trying to study an entire continent while only being able to examine a few square kilometers at a time. This is precisely the situation modern oceanographers find themselves in. Furthermore, the ocean is not a static environment. Currents, sediment, and underwater landslides can all alter the seabed's topography. This means that even areas that have already been explored may look different over time. But there is another aspect that makes the ocean especially mysterious. This is his unpredictability. Sometimes underwater vehicles detect structures that were previously unknown. For example, during their explorations, they discovered seamounts that were not on maps, or unexpected faults extending kilometers into the depths. Such discoveries do not occur because they are new, because before we simply didn't know about their existence. And this is the key point. The ocean isn't empty. It only hides a few unknown objects. It hides entire spaces of which we have only a general idea. By some estimates, a significant portion of the seafloor has yet to be mapped in detail. This means that right now, there are areas of our planet that no one has ever seen. Neither a man nor a camera, only indirect data, sound signals, and approximate models. And this creates a unique situation. We live on a planet, a significant part of which remains unknown. Not somewhere far away, beyond the solar system, but here, underwater. And perhaps it is in these unexplored zones that the most important discoveries of the future are hidden. New landforms, new ecosystems, and processes that could change our understanding of the ocean. But to get closer to these discoveries, we must first understand the obstacles a person faces when trying to look into the depths, because the ocean hides its secrets for a reason. While seamounts create the feeling of a hidden world similar to land, deep-sea trenches are something completely different. These are places where conventional ideas about the Earth cease to apply, where the depth becomes so enormous that it is difficult to imagine even in theory. The most famous of these zones is the Mariana Trench. Its depth reaches almost 11 kilometers. Even if you were to place the tallest mountain on Earth, Mount Everest, there, its peak would still not reach the surface. But even more striking is the pressure. At this depth, it exceeds 1,000 atmospheres. This means that every square centimeter experiences a force comparable to the weight of a car. For humans, such conditions are absolutely fatal. Even modern devices can only remain there for a limited time. Their hulls must be reinforced and their systems carefully designed to withstand the pressure. But the Mariana Trench is not the only such place. The oceans contain a whole system of deep-sea trenches formed by the movement of tectonic plates. They stretch along the plate boundaries, forming long, narrow basins. For example, the Tonga Trench in the Pacific Ocean is one of the deepest trenches on the planet. In some places, its depth exceeds 10 kilometers. There are also the Philippine Trench, the Kermadec Trench, and other structures that extend to depths comparable to the Mariana Trench. Each of them represents a separate world. But what makes these places especially unusual is not only their depth. These are the conditions in which they exist. At such depths, there is no light. The temperature is close to zero. The pressure is colossal. And yet, life still exists there. This discovery was one of the most unexpected in the history of oceanography. For a long time, it was believed that life at such depths was impossible. It was too dark, too cold, and the pressure too high. But research has shown otherwise. Organisms adapted to these extreme conditions have been discovered in deep-sea trenches. Some have soft bodies that don't collapse under pressure. Others possess specialized biochemical mechanisms that allow them to function in environments where normal organisms can't survive. For example, small crustaceans have been discovered in the Mariana Trench, as well as unusual species of fish capable of living at depths of more than 8 kilometers. And these are only the organisms that we were able to record. But even today, these areas remain extremely difficult to access. The number of dives to such depths can be counted on the fingers of one hand. Each of them requires complex preparation, special equipment, and significant resources. And even then, only a small area is being explored. This means that most of the deep sea remains virtually unknown. We know where they are. We know their approximate depth, but we know almost nothing about what they look like in detail. We don't know what landforms lurk on their bottoms. We don't know what organisms live there. And we don't know what processes occur in these extreme conditions. Sometimes the devices record strange structures, areas covered with unusual deposits, or landforms that are difficult to explain immediately. Sometimes strange sounds are recorded, the origin of which remains unclear. However, due to the complexity of the research, many such observations remain isolated. And this creates the feeling that deep-sea trenches are not just geographical features. This is the border, the boundary between what we know and what remains unknown. And perhaps it is in these depths that processes are hidden that could change our understanding of the ocean. Because the deeper we go, the more the very character of the surrounding world changes, and the clearer one thought becomes. We have not yet reached the limit of this dive, but if the deepest points of the ocean represent the limits of possibility, there are other landforms that are no less astonishing, less well known, but no less important. Forms that do not descend downwards, but rather create complex structures that intersect the ocean floor. The ocean preserves more than just natural forms and processes. Its bottom holds something more human, traces of our own history. And if you try to imagine how many ships have disappeared in these waters over the past centuries, it becomes clear that we're not talking about isolated incidents, but entire layers of the past, literally sunk into the depths. Every vessel that sets sail has always been at risk. Storms, navigational errors, wars, technical malfunctions. There have always been plenty of reasons for loss. And while the consequences of such events remain visible on land, things are different in the ocean. The ship disappears, and with it, the opportunity to immediately understand what exactly happened disappears. Over time, it became clear that such disappearances were far more common than previously thought. According to modern estimates, there are millions of sunken ships on the world's ocean floor, and the vast majority of them were never seen again after their demise. They simply vanished and remained where they ended. Sometimes history does bring them back. When the Titanic was discovered in 1985, it was more than just a technical achievement. It was an event that demonstrated just how deeply hidden even the most famous wreck could be. The area where it sank was known, but the ship itself remained out of reach for decades. Only with the advent of deep-sea submersibles did it become possible to see what had truly happened. It turned out to lie at a depth of almost 4 kilometers, fragmented and gradually disintegrating under the influence of time and the environment. But the Titanic is a rare case where an object was searched for purposefully. Most of the ships are not searched for. That's why ocean history consists not of known wrecks, but of thousands of unknowns. This is especially true in earlier eras, when navigation was less precise and the voyages themselves more risky. In the 16th and 17th centuries, the ocean was the main route for transporting wealth between continents. Spanish galleons laden with silver and gold crossed the Atlantic, and far from all of them reached their destinations. Some disappeared in storms, others fell victim to pirates, and still others simply vanished without a trace. One of the few examples of such a ship being found is the galleon Nuestra, Señora de Atocha. It sank off the coast of Florida in the 17th century, and the search for it took over 15 years. When it was finally discovered, it was found to contain tons of silver and other valuables. But this case only highlights the scale of the problem. If one ship took so long to find, how many more remain undiscovered? The situation hasn't gotten any easier over time. The 20th century added thousands of new objects to this list. During the World Wars, the ocean became a battlefield, and countless ships were sunk. During World War II alone, thousands of vessels were destroyed, from small transports to large warships. Many of them remain undiscovered. Even when the approximate location of a death is known, pinpointing its exact location is extremely difficult. The ocean doesn't preserve traces the way land does. There are no obvious landmarks, and the search area can be vast. As a result, even relatively recent objects can remain hidden for decades. A good example is the American aircraft carrier USS Hornet, which sank in 1942. It was only discovered in 2019 at a depth of more than 5 kilometers. For nearly 80 years, it lay there, out of sight, despite all modern technology. And this brings us to another point. A sunken ship does not remain unchanged. From the moment it touches the seabed, a different process begins. The metal gradually deteriorates, the structures become deformed, and the surface becomes coated with sediment. But at the same time, a new environment begins to form around the ship. It becomes part of the ocean. Over time, the hull becomes encrusted with organisms, fish settle within, and an entire ecosystem develops around it. What was once man-made becomes a natural feature of the landscape. Sometimes, after several decades, the ship is barely recognizable. It looks like part of the seabed. But there is a more complex side. Some ships carry not only history, but also potential danger. Vessels carrying oil, chemicals, and ammunition remain on the ocean floor. While their hulls are intact, they are relatively safe. But over time, the materials degrade, and their contents can leak into the environment. The problem is that we don't always know where such objects are. They remain hidden, just like many others. And perhaps this is what makes the topic of sunken ships particularly significant. These aren't just isolated finds. They're an entire layer of history that lies beyond our constant observation. We know it exists, but we only see a small part of it. Sometimes new technologies allow us to peer deeper into this world. Autonomous vehicles scan the seabed, creating more accurate maps. Cameras capture what was previously inaccessible. And from time to time, new discoveries emerge, ships that had been forgotten or even unknown at all. But each time, one thing becomes clear. We found only a small part, because the ocean is in no hurry to reveal its secrets. It preserves them in darkness, under pressure, in conditions where time flows differently. And where every discovery is not the end of the story, but only its beginning. Continuous ships aren't the only things that disappear in the ocean. Another category of objects makes this topic far more troubling and complex to understand. Aircraft. Unlike ships, which can drift, transmit signals, or leave traces on the surface, an aircraft exists in a much more vulnerable position over the ocean. Its journey is through the air, but in the event of a disaster, it almost always ends the same way. An abrupt, destructive plunge into the water, leaving very little information behind. when a plane crashes into the ocean, everything happens too fast. The high-speed impact with the water's surface is comparable in destructive force to a collision with solid ground. The structure collapses, parts fly apart, and within minutes, all that remains begins to sink into the depths. Then comes the force that makes the ocean so challenging to explore: currents, depth, pressure, and the lack of visibility. As a result, the disappearance of an airplane over the ocean is more than just an accident. It's an event that almost immediately becomes a mystery. One of the most famous examples remains the Malaysia Flight Airlines MH370. In 2014, the plane disappeared from radar over the Indian Ocean, sparking one of the largest search operations in history. Dozens of countries, satellite systems, signal analysis, and complex mathematical models were involved. It was hoped that modern technology would allow for the crash site to be located relatively quickly. But this did not happen. The search continued for months, then years. Individual fragments were discovered. Debris washed up on the shores of Africa and the Indian Ocean islands. But the main part of the plane was never found. It remains somewhere in the depths, and its exact location remains unknown. This incident became an important signal. He demonstrated that even with satellites and global tracking systems, we cannot guarantee that we will be able to quickly find an object that has disappeared over the ocean. Vast distances, depths of several kilometers, and complex currents make the search a task where even a small calculation error increases the search area to thousands of square kilometers. And this is modernity. Looking back at earlier periods, it becomes clear that there were many more such cases. During World War II, thousands of aircraft flew over the oceans: bombers, reconnaissance aircraft, transports. Many of them never returned. Sometimes the cause was known: weather conditions, combat, technical malfunction. But in a vast number of cases, the planes simply vanished. They were not found. They didn't leave coordinates, didn't transmit signals, and weren't tracked by radar the way they are today. And so a significant portion of these machines still lie somewhere on the ocean floor. Sometimes such discoveries do occur. Modern deep-sea vehicles occasionally discover aircraft lying on the seabed. These images look almost surreal: a hull covered in sediment, wings receding into darkness, a cabin where everything stopped at the moment the flight ended. In some cases, the objects are better preserved than expected because there is no light at depth and relatively few processes that degrade materials as quickly as on the surface. But such finds are rare. More often than not, the plane doesn't survive intact. It breaks apart on impact, and its parts scatter across the seabed. Some fragments may be carried away by currents, while others are buried in sediment. Over time, this makes detection increasingly difficult. Even if the approximate location is known, a complete picture may be impossible to piece together. A good example is an Air Flight France 447, which disappeared in 2009 over the Atlantic Ocean. Unlike MH370, the crash site was pinpointed with greater precision. However, even in this case, the search took nearly 2 years. The plane was found at a depth of approximately 4 kilometers, and only then was the sequence of events reconstructed. This shows how capable the ocean is of hiding even relatively recent disasters. But there is another aspect that makes the topic of lost planes particularly complex. This is the absence of intermediate traces. A ship can send distress signals, be seen by other vessels, and leave debris on the surface. Aircraft, especially in remote ocean areas, often lack these capabilities. If communication is lost and then a disaster occurs, only a few minutes may pass between these events. and in that time, it's virtually impossible to obtain sufficient information. As a result, the ocean becomes the last witness. But this evidence is hidden. It's located deep underground in conditions where humans can't directly observe it. Accessing it requires sophisticated equipment, lengthy expeditions, and significant resources. Even then, there's no guarantee the object will be found. Over time, the situation becomes even more complicated. Materials degrade, especially in the upper layers of the ocean where biological processes are active. Parts of the structure may disappear completely, leaving only fragments that are difficult to identify. This means that the likelihood of finding some objects decreases each year. And yet the search continues. New tracking systems are being developed, automatic transmitters capable of operating even after a disaster are being introduced, and underwater scanning methods are being refined. All of this is gradually increasing our capabilities, but the fundamental problem remains the same. The ocean is too big. It doesn't simply conceal objects, it makes them part of its environment. Over time, the plane ceases to be an airplane in the traditional sense. It becomes a fragment of the seabed, an element of an ecosystem, part of a space that continues to change. And this is the main feature. When a plane disappears over the ocean, its story doesn't end. It simply transforms into another form, a form we rarely have access to. This is why the ocean floor remains not only an archive, but also a zone of uncertainty, the place where the answers are stored, and where we still can't ask all the questions. Continue. If sunken ships and planes are the remains of tragedy and accident, there is another layer to the ocean, much less obvious and much more hidden. This is a military story, a part of history that was originally not intended for public consumption and remains partially closed even today. For decades, the ocean was not only a route and environment, but also a strategic space where operations took place that few knew about. And a significant part of this legacy still lies at the bottom. During the 20th century, the oceans became an arena for global conflict. World Wars I and II, then the Cold War. All were accompanied by the active use of maritime space. Submarine routes were laid, surveillance systems were installed, tests and covert operations were conducted underwater. And not all of this was returned to the surface. There are hundreds of submarines on the ocean floor, many of which were lost in combat or accidents. Some are known and studied, but many remain out of sight. This is especially true in deep waters, where searches are difficult. For example, the Soviet submarine K-129D, which sank in the Pacific Ocean in 1968, long remained one of the most enigmatic stories of the Cold War. Its exact location was unknown until a secret U.S. operation attempted to raise it. Even today, details of this story remain partially classified. This is just one example of how the ocean becomes a repository, not only of technology, but also of secrets. There are other cases. The American submarine USS Scorpion, which sank in the same year, 1968, was found at a depth of more than 3 kilometers. The cause of its loss remains definitively unknown. Analysis of the wreckage provided only partial answers, leaving many unexplained questions. Such stories show that even with the technology and interest, it is not always possible to fully reconstruct the picture of what happened. But submarines are only part of it. During the Cold War, the ocean was actively used to deploy various surveillance systems. Sensors, cables, and devices designed to track enemy movements were installed on the seabed. Many of these were abandoned or lost over time. Their exact number and location are not always known. Some of these systems still lie on the seabed, serving as artifacts of the conflict era. They are invisible, unused, but continue to exist as part of the hidden infrastructure of the past. There are also objects related to testing. In the mid-20th century, weapons tests were conducted, including underwater explosions. As a result, fragments of equipment, structures, and other traces of these operations could remain on the seabed. Some of these have been documented, but far from all. This creates a special category of objects, those about which only partial knowledge is available. But perhaps most interestingly, not all military installations were lost to disaster. Some were left intentionally. Old ships and equipment were sometimes sunk intentionally to create artificial reefs or for recycling. However, over time, such objects also become part of the ocean, and information about them can be lost. As a result, after decades, their origin is no longer always obvious. An underwater vehicle can detect a structure, but it is not always possible to immediately determine what it is. This is particularly noticeable in areas where activity has been high, but documentation is limited. Military installations on the ocean floor are not only equipment, but also information that often remains closed. Some areas remain unexplored for this very reason. Access restrictions, secrecy, and a lack of open data all impact our knowledge of these places. As a result, the ocean becomes not just a natural environment, but a space where geology, biology, and politics intersect, and where part of history remains hidden not only because of its depth, but also for reasons that lie outside of science. Over time, as with other objects, military technology begins to change. Metal corrodes, structures deteriorate, and surfaces become covered in organisms. Submarines, ships, and equipment, all of this gradually becomes part of the environment. But unlike conventional ships, such objects may retain features that make them more difficult to study. For example, the presence of fuel, ammunition, or other materials may pose a potential hazard. This limits exploration capabilities and requires additional safety measures. Sometimes such objects remain untouched for this very reason. But even with all the restrictions, discoveries happen from time to time. Underwater expeditions operating in various parts of the ocean sometimes discover objects whose origin is not immediately clear. These include structures unlike known ship types and fragments of equipment that require analysis. And only after some time it is possible to establish that this is part of a long-forgotten operation or lost equipment. Each such discovery adds another element to the overall picture, a picture that remains incomplete, and perhaps that's what makes military installations on the ocean floor particularly interesting. They represent a combination of technology, history, and mystery. These are not just traces of the past. These are fragments of events that took place in conditions where much was not openly recorded, and today, decades later, these fragments remain where they were, underwater, in the dark, out of constant observation. And the more we learn about them, the clearer one thought becomes. The ocean hides more than just nature. It hides what a person preferred not to show. If we talk about the ocean as a place where the past is hidden, that's only part of the picture. Because beneath the water lies not only what was lost or forgotten, it also contains what continues to function right now while remaining virtually invisible. We are talking about submarine cables, a vast network that connects continents and ensures the transfer of information between them. When we send a message, watch a video, or make a call online, it all seems to happen somewhere in an abstract cloud. But in reality, a significant portion of this data travels across the ocean, through cables laid on the seabed. These cables stretch for thousands of kilometers. They cross the Atlantic and Pacific Oceans, connecting cities and countries. Their installation is a complex engineering process that requires precise planning. specialized vessels lower the cable to the seabed, gradually unrolling it along a predetermined route. In some places, it is laid directly on the seabed surface. In others, it is buried to protect it from damage. But despite all the technology, these lines remain vulnerable. The ocean is not a static environment. Currents, underwater landslides, and seismic activity can all impact cables. Sometimes damage occurs due to natural processes, sometimes due to human activity, such as anchors or fishing nets, and then the connection may be interrupted. Historically, damage to multiple cables has caused significant disruptions in data transmission between regions. This highlights just how dependent the modern world is on underwater infrastructure. But there is one more aspect. These cables lie on the ocean floor, passing through areas we haven't fully explored. They cross plains, skirt seamounts, descend into canyons, and pass alongside trenches, and yet they remain almost invisible. Sometimes underwater vehicles spot them against the ocean floor, long lines stretching into the darkness. They look almost unreal, a thin object stretching for thousands of kilometers through space, where there's nothing around but water and sediment. Over time, they too begin to change. Marine organisms appear on their surface, and sediments accumulate around them. They become part of the environment in which they live, although they continue to perform their functions. This creates an interesting contrast. On the one hand, this is modern technology, complex and precise. On the other, it lies in an environment that remains largely unknown. But submarine cables are not only a technical object, it is also an element of the global system. They carry the majority of international internet traffic. Despite the development of satellite technology, cables remain the primary method of transmitting data between continents. This means that a significant part of modern civilization depends on objects that are outside our everyday perception. We don't see them. We rarely think about them. But they exist, at the bottom of the ocean. Sometimes ocean research intersects with this infrastructure. When laying new lines, it's necessary to consider the bottom topography, avoid hazardous areas, and choose routes that minimize the risk of damage. This requires precise data on what's beneath the water, and in this sense, cables become part of the process of studying the ocean. They are laid where information already exists, but at the same time, they pass through areas that remain less studied. This again highlights the scale of the task. Even when we build something on the ocean floor, we don't always fully understand the environment we're building in. There is another aspect that makes submarine cables particularly interesting. This is their vulnerability. Unlike land-based infrastructure, access to them is limited. If damage occurs, a specialized vessel is required to locate and recover the affected section of cable. This can take days or even weeks, and sometimes more. This means that the ocean not only hides the network, but also makes it difficult to maintain. And yet this system continues to work. Thousands of kilometers of cables lie on the ocean floor, transmitting signals that connect the world. They pass through spaces where light is almost absent, where pressure is high, and where we still don't fully understand the processes that occur. And herein lies another paradox. The most advanced technology on Earth depends on an environment that remains one of the most ancient and least studied, but even this network is only a part of what is hidden at the bottom. Because, in addition to man-made objects, there are finds whose origins cannot always be explained immediately. Objects that don't fit into the usual picture, and which sometimes become the cause of new questions. Even when viewed solely as a natural environment, the ocean already appears complex and not fully understood. But when we add to this discoveries whose origins cannot be immediately determined, the picture becomes even more ambiguous. Sometimes underwater vehicles detect objects that don't fit into known geological structures or obvious traces of human activity. This isn't necessarily something inexplicable in the literal sense, but it's often something that requires time and further investigation before we can determine what exactly we're dealing with. And it is precisely these kinds of discoveries that create the feeling that the ocean hides more than just relief and known objects. One of the well-known examples is the structure discovered in the Baltic Sea, which is conventionally called Baltic Sea anomaly. When it was first detected by seafloor scanning, it appeared as a nearly perfect circle with distinct boundaries. This sparked a multitude of speculations, from unusual geological processes to much bolder hypotheses. However, further research has shown that this is most likely the result of natural processes associated with glacial activity. However, the very fact that such an object could not be immediately explained shows how limited our understanding of some areas of the ocean floor is. And this is far from the only case. When mapping the ocean, structures are sometimes discovered that at first glance appear artificial. Straight lines, sharp angles, symmetrical shapes, all of these can create the impression of man-made objects. But more often than not, such forms are the result of complex geological processes. For example, basalt formations can form nearly perfect geometric structures. Sedimentary processes can create distinct boundaries, and underwater currents can carve lines that appear too smooth to be natural. But until a detailed study is conducted, such findings remain open questions. Sometimes underwater vehicles detect individual objects that are difficult to immediately identify. These could be structural fragments, unusual shapes, or parts of something with no obvious explanation. In such cases, time is needed. Data must be collected, analyzed, and compared with known objects. Only then will it become clear what exactly was found. But the moment of discovery itself is always a moment of uncertainty. And it is precisely this that makes such discoveries especially interesting. There is another category of observations that adds complexity. These are sounds. Hydrophones deployed in the ocean sometimes detect signals whose origin cannot be immediately determined. Some of these are later explained, for example, by ice movement, underwater activity, or biological sources. But at the time of discovery, they may look unusual. The most famous example is the sound dubbed bloop, recorded in 1997. Its nature remained unclear for a long time until it was discovered that it was associated with the processes of glacier destruction. But the very fact that such signals can be detected without immediate explanation highlights the complexity of the ocean environment. Sometimes strange discoveries are not related to nature, but to human activity, about which not everything is known. For example, seabed surveys may reveal objects that don't correspond to known shipping or military activity in the area. This may be because information about certain events remains incomplete or unavailable. As a result, the object exists, but its history is unknown. And this again creates a situation where it takes time to understand what we are dealing with. But perhaps the most important point lies elsewhere. The ocean does not have to be fully understood right away. It's an environment where processes happen slowly and access to information is limited. We acquire data gradually, step by step. And each new piece of information can change the overall picture. What seems strange or unusual today may be explained tomorrow, but until that moment, it remains part of the unknown. If you imagine the ocean floor without life, it would seem logical. Darkness, cold, pressure beyond what humans can withstand. Such conditions seem incompatible with the existence of complex organisms. And for a long time, this was exactly what was believed. Scientists assumed that at great depths the ocean became almost empty, that life there was either absent or represented by primitive forms existing on the fringes of possibility. But the reality turned out to be completely different. When the first deep-sea vehicles began transmitting images from the depths, it became clear an entire world exists beneath the ocean's surface, a world that has not only adapted to extreme conditions, but evolved according to its own rules. And these rules are very different from those we are used to on the surface. At a depth of several hundred meters, the light disappears. First, the colors disappear, then the contours, and at some point, only darkness remains, complete, unbroken, without beginning or end. In this darkness, vision loses its meaning, and life begins to change. Many deep-sea creatures don't rely on vision the way surface dwellers do. Some have tiny eyes, while others have enormous ones capable of detecting minimal light sources. Still others are practically eyeless. Instead, other ways of perceiving develop. Sensitivity to water movements, to chemical signals, to the slightest changes in the environment. But perhaps the most amazing thing is the light. In a world where there is no sun, light still exists. It is created by the organisms themselves. Bioluminescence, the ability to produce light, has become one of the most common adaptations in the deep ocean. By some estimates, most creatures living at great depths are capable of luminescence. This light is used in different ways. Sometimes for hunting. The anglerfish, one of the most famous inhabitants of the deep, uses its luminous organ as a lure. In complete darkness, even the faint glow can attract prey. When it approaches, the attack occurs instantly. Sometimes light serves for protection. Some organisms are capable of producing flashes, disorienting predators. Others, on the contrary, use a weak uniform glow to disappear into the environment. And sometimes light is a way of communication. Signals that we cannot see without special equipment can transmit information between individuals. But the appearance of these creatures is a separate story. Deep-sea fish and invertebrates often look like they don't belong on our planet. Their transparent bodies, elongated shapes, unusual proportions, and organs have no equivalent in land animals. This is the result of adaptation to conditions that are not found anywhere else. Pressure, for example, affects the very structure of the body. Many deep-sea organisms have soft, flexible tissues that are not destroyed by the enormous force of the water. Their bones and muscles are structured differently than those of animals living closer to the surface. Temperature also plays a role. In the ocean depths, it remains stable and low. This slows metabolism, and many organisms live at a different pace. Their movements are slower. Their reactions are not as rapid as those of surface species. But this does not mean that they are less effective. On the contrary, in conditions of limited resources, every survival strategy becomes precise and well thought out. Food is rare in the deep ocean. Most of it arrives from above, in the form of organic remains that slowly sink. This is called marine snow. Small particles, the remains of organisms, everything that was once part of life on the surface, gradually settled to the bottom. For many deep-sea creatures, this is the main source of energy. But there are also predators. They've adapted to the fact that prey is rare. Their bodies can be designed to capture and hold any opportunity. Enormous mouths, distensible stomachs, and the ability to go long periods without food, all part of their adaptation. Sometimes such organisms can swallow prey that is larger than their own size. It seems impossible, but in deep waters it becomes an advantage, because the next chance may not come soon. But even with all these features, life in the deep ocean remains incompletely studied. Every new dive brings discoveries, new species that were previously unknown, new forms that do not fit into existing classifications, organisms whose behavior and structure require further study. And this still happens. This means that we are not simply studying an existing list of species, we are constantly expanding it. And perhaps the most important point is that this world is no exception. It occupies a huge part of the planet. The ocean depths are not a small, isolated region. They span thousands of kilometers and constitute a significant portion of the Earth's biosphere. And yet, it remains one of the least studied. For a long time, it was believed that all life on Earth depended, directly or indirectly, on sunlight. Even if an organism lived in the depths of the ocean, it was assumed to obtain energy through a chain, from plants and plankton living on the surface. Light was considered the foundation of the entire biosphere, a universal source without which complex ecosystems were impossible. But at the end of the 20th century, this idea was seriously revised. When scientists first discovered hydrothermal vents on the ocean floor, they expected to see a geological phenomenon, hot water gushing from the Earth's depths, and perhaps rare life forms existing on the fringes of survival. However, the reality was far more unexpected. Entire ecosystems, complex, active, and teeming with life, were found around these vents. At depths where sunlight never penetrates, where the temperature of the surrounding water is close to zero and the pressure is enormous, there were communities of organisms that not only survived, but also developed. This meant one thing: life can exist without the sun. These ecosystems were based on microorganisms capable of obtaining energy not from light, but from chemicals. This process is called chemosynthesis. Unlike photosynthesis, which relies on solar radiation for energy, chemosynthesis utilizes compounds emanating from the Earth's depths, primarily hydrogen sulfide and other substances found in hot springs. These bacteria become the foundation of the entire system. They produce organic matter, which is then used by other organisms. Entire food chains form around them, completely independent of processes occurring on the surface. This is why hydrothermal vents are often referred to as oases of the deep. One of the most impressive elements of these ecosystems are giant tube worms, which can reach lengths of over 2 meters. They lack a conventional digestive system. Instead, they harbor symbiotic bacteria inside their bodies, which provide them with energy. This is an example of how much the very structure of an organism can change if it develops in conditions different from those it is used to. Shrimp, crabs, mollusks, and a host of other creatures live alongside them, forming dense communities around the vents. All of this is concentrated in relatively small areas where heat and chemicals emerge from the Earth's interior. But these zones are not static. Hydrothermal vents can appear and disappear. Their activity depends on geological processes occurring beneath the seafloor. This means that the ecosystems that form around them can also disappear or shift. Life here is constantly adapting to change, and this once again highlights how dynamic the deep environment can be. But hydrothermal vents are not the only place where such systems exist. There are also so-called cold seeps, zones where methane and other substances emerge from the seabed at lower temperatures. Ecosystems based on chemosynthesis also form there, although their structure differs. This means that such life forms may be more common than previously thought. And this discovery has implications beyond just understanding the ocean. It changes our perception of life in general. If complex ecosystems can exist without sunlight, this expands the boundaries of what's possible. It means life can emerge and thrive in conditions previously considered unsuitable. And that is why such research is often linked to the search for life beyond Earth. For example, an ocean is thought to exist beneath the icy surface of Jupiter's moon Europa. If processes similar to hydrothermal vents exist within it, life could theoretically exist there. Thus, the Earth's ocean becomes not only an object of study, but also a model that shows what life might look like under different conditions. But even without this comparison, one thing remains clear. We only partially understand how these systems work. Each new study yields additional data, but also raises new questions. What other forms of life might exist in the deep? How diverse are these ecosystems? And how many of them remain unknown? The answers to these questions are yet to come. Because even now, when we already know about the existence of life without light, it becomes clear this is only one part of a much more complex picture. And perhaps the most important discoveries in this area have not yet been made. Even after all the discoveries that have already been made, the ocean remains a place where new discoveries are made regularly. These aren't rare events separated by decades, but an ongoing process. Every year, expeditions working in different parts of the world record what no one has ever seen before. And it's not just that new data is emerging. Our very understanding of the scale of the unknown is changing. When modern underwater vehicles explore previously inaccessible areas, they often discover organisms unlike any known species. These aren't necessarily large or conspicuous creatures. Sometimes they're small organisms whose features become apparent only upon closer examination. But they can change our understanding of ocean life. For example, in recent years, numerous new species of deep-sea fish and invertebrates adapted to extreme conditions have been discovered. Some have transparent bodies through which internal organs are visible. Others use light for camouflage or communication. Still others have biological mechanisms that are still not fully understood. But the discoveries concern not only living organisms. Sometimes expeditions discover new geological structures, previously unmapped seamounts or ocean floor areas with unusual topography. This demonstrates that even the basic ocean map remains incomplete. This is especially noticeable in remote areas where research is rare. There, each new dive can lead to the discovery of something previously unknown. Technology plays a key role here. Modern autonomous underwater vehicles are capable of operating without human intervention, exploring large areas and transmitting data in real time. They can descend to previously inaccessible depths and remain there longer than manned vehicles. This significantly expands the research possibilities. But even with such technologies, the process remains slow. The ocean is too vast to be explored quickly. Each expedition covers only a small portion, and even with constant research, it will take a long time to obtain a more complete picture. And that's why new discoveries continue to happen. Every time we think we have reached a certain level of understanding, data emerges that shows it is just an intermediate stage. Sometimes these are new species, sometimes new processes, sometimes unexpected interactions between already known elements. This creates the feeling that the ocean is not just holding the unknown, but is constantly revealing it little by little. And this is one of its features. Unlike many other fields of science, where major discoveries have already been made, and only the details remain to be explored, oceanography remains in a state of active knowledge expansion. There is no sense of finality here. There is only forward movement. But this movement also comes with new questions. Each discovery not only provides an answer, but also creates new avenues for research. Why is this organism structured this way? How has it adapted to its conditions? What processes underlie its existence? And the more we learn, the more complex the overall picture becomes. This is not a simplification, but on the contrary, a complication of understanding, because the ocean is a system in which many processes interact simultaneously: geology, biology, chemistry, physics. All of these are intertwined, creating an environment that is difficult to describe with a single model. And that is why every new discovery matters. It doesn't just add information, it changes the context. It shows that what seemed rare can actually be common. Or, conversely, that what was considered common can actually have unique features. At first glance, it might seem that in the 21st century, there are no truly unknown places left on Earth. Satellites map the planet's surface with high precision, navigation systems track the movement of objects in real time, and technology allows us to peer into the most remote corners of the world. But the ocean is an exception, and this is not an accident. The reason is that the conditions that exist in the deep ocean create a number of limitations that cannot be fully overcome even with modern technology. These limitations are not always obvious, but they are the reason why much of the ocean remains only partially explored. The first and most obvious factor is depth. At the surface, the ocean may seem accessible, but at depths of just a few hundred meters, conditions change dramatically. Light fades, temperature drops, and pressure begins to rise. With every tens of meters, it increases, and at depths of several kilometers, it becomes extreme. This means that any equipment must be specifically designed to withstand such conditions. Conventional materials are unsuitable. Even the slightest design error can lead to the destruction of the apparatus. This makes the development of deep-sea technology a complex and expensive process. But depth is only part of the problem. The second factor is darkness. At great depths, there is no natural light. This means observation is only possible using artificial light. However, strong light can affect the behavior of organisms, while weak light limits visibility. As a result, even with a camera, we see only a small area of space. The rest remains hidden. The third factor is scale. The ocean covers most of the Earth's surface. Even if we consider only its bottom, the area to be explored is enormous. Each dive, each expedition, covers only a small portion. When compared to land, the situation becomes clear. On land, we can move relatively freely, use transport, and conduct long-term research. In the ocean, however, every action requires preparation, equipment, and resources. This slows down the process. The fourth factor is cost. Ocean exploration requires significant investment. Specialized vessels, submersibles, equipment, and teams of specialists. All of this makes each expedition expensive. As a result, research is not conducted as frequently as would be desirable, and this limits the amount of data that can be obtained. The fifth factor is accessibility. Some ocean areas are remote and difficult to access. Storms, icy conditions, and unstable weather all impact the ability to conduct research. Even if the equipment is ready, conditions may not allow its use. And finally, there is one more aspect that is not always taken into account. It is the complexity of the environment itself. The ocean is more than just a space filled with water. It's a dynamic system constantly changing. Currents, sediment, and chemical processes all influence what we observe. This means that even the data obtained may be temporary. What is recorded today may change over time. All these factors together create a situation in which the ocean remains difficult to study. This does not mean that there is no progress. On the contrary, significant advances have been made in recent decades. Maps have become more accurate, equipment more reliable, and methods more effective. But even so, it becomes clear that we are only at the beginning of the journey. We know more than before, but still not enough. When we say that the ocean remains poorly understood, it sounds like a general statement. But behind it lies a much more specific idea. There may still be things lurking at the ocean floor that we don't even know exist, and this is not an exaggeration. The history of science has repeatedly shown that the most important discoveries occur not when we search for something specific, but when we encounter something unexpected. The ocean, in this sense, remains the ideal environment for such discoveries, because it is huge, complex, and in many ways hidden from direct observation. If you imagine the scale, it becomes clear that even with active research, we only cover small areas. Between them, there remain spaces that have never been studied in detail. And it is precisely in these spaces that new landforms, new ecosystems, and new processes may be found. For example, scientists already suspect that there may be many more seamounts and structures in the ocean than mapped. Some may be small, while others may be significant in size, but simply undetected due to limitations of research methods. The same applies to life. Every expedition into the deep yields new species. This means the list of organisms living in the ocean is far from complete. Moreover, there is reason to believe that the most unusual life forms may be found in the very zones we have explored the least. This is especially true in extreme conditions. Deep-sea trenches, hydrothermal vents, and areas with high chemical concentrations are all potential habitats for organisms with unique properties, and we are just beginning to understand how they work. But it's not just about biology. There are also geological processes that remain incompletely understood. The movement of tectonic plates, the formation of new structures, underwater eruptions, all of this is happening constantly, but we only record a fraction of these events. This means that processes may be occurring on the ocean floor that we have not yet directly observed. Their consequences may be visible, but the mechanisms themselves remain hidden. There is one more aspect that is worth considering. The ocean is not an isolated system. It is linked to the planet's atmosphere, climate, and geology. This means that processes occurring deep within the planet can influence larger systems. For example, underwater gas emissions can affect the chemical composition of water. Currents can affect heat distribution. Ecosystems can affect the circulation of substances. But to understand these connections, more data is needed. And this is where space for future discoveries arises. Modern technologies are gradually expanding our capabilities. New devices capable of operating at great depths are being developed. Mapping methods are being improved. Systems capable of collecting data over long periods of time are emerging. But even with this progress, it's becoming clear the ocean won't be fully explored anytime soon. And perhaps this is what makes it special. It doesn't open up right away. It requires consistent and long-term research. But that's what makes it interesting. Because unlike areas where everything is already known, the ocean remains a place where unexpected discoveries are possible, where new data can change our understanding of how life works, how the planet is formed, and what processes underlie its functioning. And if we look back at everything that has already been considered, from the bottom topography to the objects left by humans, from life in the deep to ecosystems without light, it becomes clear that the ocean cannot be described by one simple model. It's not just water. It is a complex, multi-layered system that combines the past, the present, and processes that are ongoing right now. And that's why, when we talk about what's hidden at the bottom of the ocean, we're not just talking about what's already been found. We are talking about what remains to be discovered, and about something that may change our understanding of the world more than any previous discovery. Because there is space beneath the surface of the water that is still waiting to be seen. If we go back to the very beginning, to the simple question, what is lurking on the ocean floor right now, it becomes clear that the answer is much more complex than it might seem. Because we are not talking about one phenomenon or one object. We are talking about the whole world, a world that exists parallel to our own, yet remains beyond our everyday perception. We traverse oceans, see their surfaces, observe storms and calm waters. But all this is only a thin layer over what lies deeper, and the further we progress in our study, the more obvious it becomes. The ocean cannot be perceived as something unified and completely understandable. It consists of many levels. On one level, there's the terrain, complex and varied, with mountains, canyons, and basins whose scale is difficult to comprehend. On the other, there are traces of human activity, ships, aircraft, military installations, and infrastructure that, over time, become part of this space. Even deeper, there is life adapted to conditions that seem impossible. Organisms that exist without light, ecosystems based on chemical processes, life forms that have no analogues on the surface. And all this exists simultaneously, right now. But at the same time, a significant part of this world remains outside our observation. We know of its existence, but we see only fragments. Each new study adds details, but does not complete the picture. On the contrary, it reveals how much more complex it is than previously thought. This creates a special feeling. It feels like we live on a planet we don't fully know. And this is not due to a lack of interest or technology. This is due to the very nature of the ocean. He doesn't deliberately hide his secrets. He simply exists in conditions that make them difficult to access. Depth, pressure, scale, all of this creates a barrier that cannot be easily overcome. And that is why the learning process takes time. But there is another side to this. Every discovery in the ocean has a special significance because it doesn't just add new information. It expands the boundaries of what we think is possible. When sunlightless ecosystems were discovered, it changed our understanding of life. When new species were discovered in the deep, it became clear that diversity was far greater than previously thought. When previously unknown objects were discovered, it showed that the ocean story had not yet been fully told. And all this is not happening in the distant past. And now, the ocean remains one of the last frontiers on Earth, not because it is far away, because it is deep below us. And perhaps this is precisely its main feature. We're used to searching for the unknown somewhere far away, in space, on other planets. But on our own planet, there's a space that remains no less mysterious, a space we are only just beginning to understand. And perhaps most importantly, it is not what has already been found, and what is yet to come. Because if even now, after decades of research, the ocean continues to surprise, one can assume that the most significant discoveries have not yet been made. They are in places where we haven't been yet, in areas yet unexplored, in depths where no spacecraft has yet descended, in systems we're only just beginning to notice. And when we talk about the ocean floor, we're not just talking about a place. We are talking about the process of cognition that continues, and which will probably continue for a very long time. Because the ocean is not just a part of the planet. This is the world that remains beneath us.